Hello students, in class 12th I have told you about the size of the nucleus, nuclear forces and nuclear binding energy curve. When I taught you the energy in binding curve, I told you that after the mass number A greater than 170, the nuclear binding energy decreases, and for uranium-235 it is approximately 7.6 mega electron volts, and as the mass number increases, the nucleus become more unstable, and at that time the nucleons in the nucleus are so much that it cannot hold all nucleons together. Then takes place a new phenomenon called the radioactivity. So today I will take the radioactivity. Actually, this phenomenon was discovered by Henry Becquerel. The spontaneous decay of nucleus is called radioactivity. This is what the definition of radioactivity is called radioactivity. It was discovered by Henry Becquerel the radioactive nucleus emits the particles and the decay continues till the nucleus does not get a stable nucleus. A stable nucleus. So the radiations emitted by nucleus are called Becquerel radiations or Becquerel range. and the radioactivity is nuclear phenomena. So whatever the radiations or the particles which are emitted by the nucleus were studied by the Rutherford in the presence of electric and magnetic field. Rutherford studied the nature of particles emitted during the decay of nucleus, and this is suppose like this. We are having this is suppose a container, this is radioactive element. Here we apply a positive plate, this is a negative plate. Then some of the particles are going towards the positive plate and some are going towards the negative plate and some goes, they are not reflected at all. So this is radioactive elements. On the study of particles in electric and magnetic field, Rutherford divided them in three types. Here it will not be, I think you have studied this radioactivity in the 10th class also. And you know that this was first discovered by the Henry Becquerel in the uranium, when he saw that the uranium placed it affects the photographic plates. So he said that there are certain radiations which are not visible, but they affect the photographic plate. So he gave this phenomenon named the radioactivity, and such elements are called the radioactive elements. And the particles that or the radiations which were emitted by the nucleus were studied by Rutherford in presence of electric and magnetic field. So on this basis, the Rutherford divided these particles into three types. First, alpha particle. Alpha particles. Alpha particles, they are positive charge. and they are the nuclei of helium. So the charge is equal to plus 2e. This helium has the two nucleons. There are 4 nucleons, but there are 2 proton and 2 neutron. So the charge on the nucleus is plus 2e, and the alpha particle have the mass approximately 4 times the mass of the proton. Mass of alpha particle equal to 4 times the mass of proton, where mp equal to mass of proton. And second particle he named the beta particle. Beta particles. These are negative charge, having the nature of electron. So charge on this particle is equal to minus 1.6 into 10 raised to the power minus 19 coulomb, and mass 9.1 into 10 raised to the power minus 31 kg. So these are called the beta particles. Later on I will tell you at the time of decay of these particles with more properties, but now I am taking only that what kind of particles were emitted in the radioactivity. Third particle is not affected by the electric and magnetic field, so it was given the name gamma particle. Gamma particles. They are not affected by electric and magnetic field. They are neutral particles. And as such they have no charge, so charge is equal to 0, and these particles are termed as the photons. Gamma particles are photons. So they have zero mass at the when they are at rest, and when they move, then they have the velocity equal to the velocity of the light. So this is what the properties of the radiations that were studied by the Rutherford. So you like, share and subscribe this video. Thank you.